Express yourself regularly. I'm Ray Myers. Welcome to Craft versus Cruft. And previously, we did the first domain-specific language to be featured in 2025, the year of DSLs, which is regular expressions. So I went over some of the code that was written by Rob Pike as an example of a simple regular expression engine, just a few dozen lines of C code. Very interesting stuff there. That was featured in the book Beautiful Code. And I promised you next we were going to actually define the grammar for a fuller subset of regular expressions. So we're not going to be thinking about the behavior so much today. We focused on that last time, but this is just going to be the grammar of it. And we're going to use a tool called Antlr, which is one of the most popular parser generators, to generate a parser based on a context-free grammar we're going to give it. So this is roughly sketched out like these are the features of regexes we want to support. And this gets you pretty far in regexes. You know, they're quite simple for how powerful they are. So you could type just any old character that doesn't mean something else, and it would match that character. You can escape something. If you need to, you know, match against one of these other symbols that means something, then you can use a slash to escape it. Dot will match on any character. A plus will take something that you've matched on and match one or more of them. Star is the same thing for 0 or more. Question mark is 0 or 1 of the thing that you've just mentioned. And you can use parentheses to group things, which has the function both of extracting that part of a match often to retrieve later. Also, you can, you know, modify a group with one of these characters here. And then we have these things in brackets, which are called char classes. So with that, you could list several different characters you might want to match, or you can do ranges of characters using a hyphen here. So these are a little more elaborate. Now, we're going to just go through and grow out an Antlr grammar that will handle this subset of regular expressions. You won't need to do this in a real situation, right? You won't need to write a parser for regular expressions, most likely. You know, one of the advantages of regex is that it's supported in about every programming context you already have. There's something like it ready to go. But this will be useful in understanding how we sketch out the syntax of a domain-specific language, so then we can use that in other situations, maybe defining our own. So what we're doing is a bit meta here. Language engineering, language tooling is very meta because there are going to be regular expressions that appear in the context of defining this grammar, because Antlr for the tokenizer rules does allow you to use regular expressions. And so I hope the meta nature of this doesn't get too confusing, but it does kind of come with the territory. So we have here a very simple Antlr rule, which is start. By convention, I'm calling what we enter the grammar in start. You don't have to call it that. And here we have a railroad diagram on the right here, indicating what kind of patterns that accepts. And it's just EOF. So like start, you need an empty document. That's it. So this is not very useful, right? But we could also say, you know, we accept the letter A, right, which will define by default a terminal, what's called A, which is a Lexer rule. I'm going to be using some of these terms, and if you don't know them, this isn't going to be the best introduction to what all those terms are. You're going to see them applied, but I recommend learning about context-free grammars and about Antlr if you'd like to do a deeper dive. I'll link some resources. Now, where we want to get ultimately is to parse this non-trivial regex that matches email addresses, not in a standards complete way, by the way. So, you know, don't actually use this in production, but this is a pretty respectably sized regex that uses, you know, all of the features that we're going to see. Before we get to that, let's make it just match against the letter A like we started out with. So I'm in VS Code with an Antlr extension right now. And if I run this guy, I should be able to get a parse tree coming out of that. Very trivial parse tree. All right, so it has successfully gotten this. It's giving T1 because I didn't give a name to that lecture rule, so it just gave it its own name. And there's just an A there. So this is like pretty useless so far, but everything is working okay. We've got our kind of edit, run, debug cycle. So let's just look at adding these features one by one. We want to be able to match just any literal character, not just this one, right? So let's put in a different character, and this should fail, right? Okay, so you see what it looks like when it fails, and it's like it didn't find anything. It didn't match. It's red. So let's make a lecture rule here for a character, char. And notice I'm actually using the regular expression dot to define this, but that's just because Antlr uses that notation, just like regex does. It's not because it has anything to do with the fact that I'm going to define that in the grammar itself. That'll come later. So what can start be? Start of the parsing, I could have a character. That's fine. So does that work? Yes. And now no matter what character I feed in, it should work. But can I have many characters? No, I just said I can have one. So we gotta support that, right? This is a problem. So I can use, again, similar notation than appears in regex to say you should parse many of these char tokens. And then that works. Great. So what else can we have? We can have a literal character, and we can have an escaped char as well. So I'm going to put this above it, and it does need to be in this order, or at least in some cases the order matters. Here we're getting meta again because I need to escape slash, because slash is also used for the escape character in this context, right? So there we go. Now let's exercise that. So can I do slash and then dot here? Parsing again. All right. And it said, hey, I got an unexpected thing here. It did parse into the escaped token, but start is not allowed to have an escaped token, right? So something that's going to come up again and again here, and it can be a little subtle to understand, is that there are two passes to how most context-free grammar parser generators, like Antlr, work. There is a lexer pass and a parser pass. And the lexer will determine what little chunks there are, and then the parser grammar, can define more elaborate rules of how those chunks get to appear. But the reasons for that are kind of subtle. It would seem like one pass and one type of rule would be easier, but in practice, it's often better this way. So what if we just say you can have a char, or you can have an escape thing, and you've got many of those, all right? Okay, now it'll parse. It's not very meaningful, like this is just a series of tokens, but it does work. So, and the next one I think we'll have to get more structured and define some more parser rules. The next one here is the any char, right? So let's call that dot. And if we were just being, simplistic here, we could put it in there. And now we've got a dot that's escaped and a dot that's not escaped. So these need to work correctly. Yeah, so that didn't work right. And I think what I need to do, it's saying like S is a dot, because I've said like dot can be anything. So what I really mean is it needs to be the literal dot. See where this kind of meta nature can be confusing. As you see now, we've got our escaped one and we've got our literal dot here. So this is all parsing as it should, I think. Now, let's break down this into saying like what it actually is, like a char or an escaped thing or a dot. That is, I'm going to say a matcher. And so now you start and we have many matchers in a row. All right, so let's see what this looks like now. So this should still match all the equivalent things, but notice the structure of the parse tree has changed, right? Great. So all our matchers are one character long. This is not that interesting. We want to be able to modify our matchers with these modifiers, a plus, a star, a question mark. We could, define this any number of ways, but let's say that there is something called a match expression, right? So match exper. Are you team exp or team exper? So at the start, we want to match actually a series of match expers, not matchers. And a match exper is simply a matcher followed by a modifier. And matcher is what we already defined, but a modifier is one of plus, or it might be star, or it might be question mark. Now, it will define, RegExr rules for each of these types of tokens, but I care about the order, so I usually like to go ahead and define these myself, because the order that these match in can matter. And I want, for instance, these to match after this, before this. Seems appropriate to me. So question and then star. So let's give an example that uses some of those, right? We'd have one or more D's. We'd have S star, gives Z a question mark. All right, so it successfully parsed these. Let's look at the structure of it, see if it's doing the right thing. We've got one match expression that's got a matcher of Z and a modifier of question. I like that. We've got a match expression of F and then a modifier that is of type escaped. I don't actually like that. I don't think that is correct. I think one thing that's going wrong with this is modifier is actually optional. Like we just maybe have a modifier. So yeah, it matches very differently when we make modifier optional, and it'll attempt to just go and find the next matcher if it's unable to match that. I feel like though that it should not have successfully parsed this either. So and indeed it didn't. There was a parse error there, and it just didn't show up successfully in the extension here. So that was, I think, not an Antlr bug, but possibly an extension bug with this visualizer. So we've gotten pretty far here. We've gotten literal character and escape character, any character, one or more, zero or more, 0 or 1. Next is group. So this is going to get a little more elaborate. So what could a match expression be? It could be a matcher and a modifier. And a matcher can be any of these three things, but I guess a matcher can also be a group. So match expression's got a matcher and a modifier optionally. Then a matcher is one of these three things, but I guess a matcher can also be a group. Now let's define what a group is. A group is a left paren followed by, I think, one or more match expressions, and then a close paren. Do you agree? And like I said earlier, I like to always make sure I'm defining my tokens. So let's give that its own RegExr rule here. and we'll call this lpar and rpar. We could also, like refer to these by their name here, but it can be easier when they're just a single character to refer to them this way. Makes the grammar a little more readable. So running this, and we're not using it yet, so as we expected, it's just parsing the same. Let's put this one in a group. A group of one there, and this one in a group. And my group also has a modifier. Let's try that. All right, this has gotten much more elaborate. So let's slow down, make sure that this is actually parsing how we think it is. This does show how scalable using a BNF notation to find a grammar is, because I just made the types of expressions that can exist in this language significantly more complex. And it took like a 2-line little change here, So we have a match expression. That match expression has a matcher. That matcher is a group. Open paren, close paren. In between it, we've got a match expression again, which has a matcher. And that matcher is simply the character Z. Is that true? Yes, I agree that is correct. It unpacks very big, but that is essentially the parse tree we ought to be creating here. And that has a modifier, which is a question mark around that whole group. So that's nice. And then we still have F. And going to the next one that's a group here, we have this more complex group, open paren, and we have a match expression of G, character literal, and then the group has a second match expression, which has a matcher of D and a modifier of plus. And then around that entire match expression of the group, there is a modifier this time of star. All right, so this looks to me like a correct parse tree for this regex. So awesome. We've already implemented groups. I mean, we didn't make them behave in any way, but we at least have a parse tree that accounts for them. So then we have these char classes. This one is going to be a little more tricky because the way that characters behave inside the brackets in a char class is a little different than they behave in other places. You'll see what that means. But one way to handle this within the feature set of Antlr would be to use what are called lexer modes. But for simplicity, I'm going to attempt to define these char classes in the way they're supposed to be. Without a different lexer mode, we might have to repurpose some things that are allowed to appear that have a special meaning outside of a char class. You'll see what that means. So it's going to get a little hairy, but it should work okay. Now, a matcher can be a group. A matcher can also be a char class. I believe it's right to say that it's a matcher. It's not like some other kind of thing. And we have open and close bracket, define lbrac and rbrac in the parser rules. Now, what can you do here? You can have a range. So let's define an example of this, right? A to Z is like the quintessential char class, right? So you have a dash, and is it a char dash a char? And if we wanted to, we could give these labels. And then when the parse tree is assembled, we'll be able to address them by that, right? Because when we have multiple things of the same rule, we have to be like the first char and the second char, it's sometimes nice to give them names, but it's optional. It's just a convenience. So then if I run this again, I should be able to see. Like I said, I like to define all my characters. So I'm going to say we have a dash. It's a RegExr rule, so it should be uppercase. There we go. Char class with 1 char range, A to Z. All right, yeah, I think this is a correct parse tree. So let's look at a more complicated character class here, right? We could have A to Z. We could have 0 to 1. Usually you would do like 0 to 9. So let's just do that, not to be confusing. And then you can also have underscore, or you could have dash. So this is valid to do in regex for better or worse. So this is something I wanted to make sure I handled. You can use dash not in a range within a char class. That is allowed. If you don't have character dash character, then it could just be a list of characters. So this could be like 1, 2, 3. Like we accept all these characters. So in that sense, after you list all the ranges, like you could also have just some individual characters you're listing. One of them might be a dash, right? Is that confusing? I agree that it is. But let's try and handle it. First of all, we need to accept multiple of these char ranges, right? That won't parse right now, right? It's like, hey, I've got extra stuff. What is this? What is this doing? So that's fine. We'll just say, hey, we need multiple char ranges. All right. So that much works. That was very easy to add. See, this is why like it's often easier to maintain a grammar in this kind of notation than it might be to directly maintain a recursive descent parser, though there can be other advantages to that. So now let's add these extra characters. So we know we support individual characters, even the one that's a special character in another context, right? So that is not going to work. It's confused. So a char range, let's say, it could be from something to something, or it could just be a character. Is that going to work? Okay. Well, that'll work for the char, but it can also be a dash, because within this bracket situation, like dash can sometimes, and some of these others can be treated as a character in those situations. Now, how we organize and name these things is kind of up to us if we even give them names. But just pretending as though I'm later going to traverse this parse tree and try and like make sense of it, encode and interpret it, I'm going to give this a name that I normally might, right? Like a solo or a single char range is just like going to be one that only has one character in it, and it might be char, it might be dash, it could be probably several of these other things, right? You might want to do it a different way, but that makes sense to me right now. All right, so we've successfully taken that in. Let's actually go over to our regex matching website here. What else kind of unintuitive things can we do with char classes? We can have dot in a char class. Now, what does that mean? So that will match dot, but it won't match just anything. So here we see that when you're within a char class, dot doesn't mean what it means in other places. What about, can we just have an open paren? Right? Yeah, that'll match. It'll just treat the open paren as a character. It won't be a group. You don't have like a group within a char class. So this is where like, this is where RegExr modes would have potentially helped us not have like extra tokens that we'll now need to account for here. But I'm just going to handle it within the parser rule. So this might be lpar, it might be rpar. Indeed, it might be dash, right? Yeah, we got that. And it might be the dot. And there's probably like other things that we may need to account for here, but this is just giving you an idea of how we could go about handling this. All right. So now if we have, for instance, a an open paren there, we should be able to go back and parse it, and yeah, it's coming in as a char range. It understands that I'm not trying to start a group or something, and it does successfully parse. Great. So we've gotten pretty far. What do you say we go back and look at that sudo email regex? Like, are we ready to parse this yet? Do you think? Take a look at it. We missing anything? Well, we haven't seen a modifier after a char class yet, but I think that should work okay. We have dot being used in here, but that should be okay. We have plus. We might not have accounted for that yet. Plus within a char class. But there's also this like start indicator and end indicator, with caret being this much match the start of the string, and $sign meaning this much match the end of the string. We haven't accounted for that yet, right? So that's also something that we're going to support. But those only make sense at the beginning and end. So this kind of, depending on the execution mode you're running a regex in, would kind of make it only match right at the beginning or the end of a string versus just, finding the pattern anywhere in the middle. So it really only makes sense to have start at the start and end at the end. You wouldn't have it like in the middle of the expression, so let's not bother accepting it there. And start is caret, and is $. All right, something's gone very wrong here. Let's take a look. Zero to 9, and then unexpected dash. So I think we're in this first char class here. We have 0 to 9 underscore, which is a solo char range. That's good. And then plus, right? So we didn't say that plus could appear in this context. Maybe that's what is a problem for us. Now we could look through and say, like, okay, is it really putting all these things in the tree where we expect them to? It's easy for us to make sure that. But I think that we're probably okay. Let's just look at like for instance, the last one, right? The last match expression. We have this char class, open bracket, A through Z is one char range. Capital A through capital Z is one char range, again, within the same char class. Kind of using char and char pronunciations interchangeably here. Most people are on one side or the other. Apparently, I'm a fence sitter. So 0 through 9 is one char range, and dash is a solo, dot is a solo. Good. And then we have the modifier of plus. So yeah, we have successfully parsed this email regex. As you can see, the grammar is quite small as we define it here, just 7 rules, and then a bunch of lecture tokens here. Just real quickly, we can step through the railroad diagram for these rules. If you like, we got start, match expr, matcher, modifier, group, char class, and char range. Hope you enjoyed. Let me know which DSLs you would like to see covered next in 2025, the year of DSLs, at least until AI web's programming away, right? Wink, wink. As Lao Tzu said in the Tao Te Ching, with patience, the most tangled cord may be undone. Thank you.